remember seeing a derivative problem like this back in college, and I was like, what do I do? I mean, it looks complicated, right? But in this dojo, I'm going to make this easy for you because we're going to absolutely crush it in just a few minutes, so you're prepared for your next exam. Now, if I haven't introduced myself, let me go ahead and do that before I dive right in. I'm Sensei Dave, and I used to tutor students like you back in college, and I'm actually a software engineer where I get to work on some fun stuff. If any of you viewers are going into engineering, let me know in the comments below too. I've even made a really fun Number Ninjas math game that you can check out in the description below for your mobile device if you want to keep your mental math sharp. Now, diving right in, notice that this has a composition of functions because we've got an outer function, the inverse sine function here, also known as arcsin, and then we've got this inner function. And wouldn't it be nice if the inner function was a lot simpler and it was just, I don't know, x? Well, why don't we make it look like that? Because we can just let the inner part be a new variable called u. You're not required to do this, but I like this method personally because it simplifies things and it's easier to not make mistakes on your test. And now that you've made this substitution, we can now use what's known as the chain rule when you're dealing with composition of functions like what we have here. Because of the chain rule, it's telling us that our final answer, dy over dx, is going to be the derivative with respect to u of this inverse sine function of u now, because we've made a substitution, but then you multiply it by the inner part's derivative, which is going to be the derivative with respect to x of this u part. And so this right-hand side looks tricky, right? Because we're dealing with something with respect to x, but then the expression itself does not have an x. It's a whole other letter. But we'll get to that, so hang on. I'm going to start with the left-hand side first, because the inverse sine function of u, when you take its derivative with respect to u, it's just like an x, right? But we have an u, so it's going to be this expression here. But then for the right-hand side, it's not a problem because what we can do now is we can simply take the u's that we see and just plug back in what we know u is. It's just e to the 4x minus 6x, right? So the left-hand side now, the radical is done, right? And you could try rewriting this. I'm not going to. But for the right-hand side, all that's left to do now to solve the problem is to take the derivative with respect to x of this part. And that's straightforward because everything is in terms of x. 6x's derivative will be 6, but then, ooh, wait a second. What do we do with e to the 4x? Can you tell me in the comments below? Okay, if you don't see it, here's your hint. It's another chain rule problem, right? Where the outer function is an exponential function, and then the inner part, the power, this 4x, you're going to use the same strategy we just did above. And if you want to know what the answer to the derivative of e to the 4x is, it's 4e to the 4x right here. So as you see with this final expression, this looks like the problem is done, right? And I'm really hoping that you found this video valuable. And if you want more practice for using the chain rule before your next exam, check out the next video you see on the screen.